Performance time is coming to an end. Nothing will ever be the same. I still got no friends but virtual users. The soak tests have come to an end. It's performance time. So here we are at the end of all things, the end of time, the end of performance time. This will be the last podcast episode of the Performance Time show. Next time I release a pod, it will be for my new show, Slight Reliability, where the goal is that we'll learn SRE, site reliability, one day at a time. To wrap things up, I wrote a blog on LinkedIn called Wrapping Up 13 Years of Performance Engineering. And I want to talk about that today in a more conversational way. I won't cover everything from the blog, but I would like to discuss the key things that I've learned over that time. The first thing I wanted to cover is to always think about the customer. So what does that mean? It means don't forget the reason why you are testing. It's about risk or opportunity for our customers, whether those customers are internal staff, maybe another system, or actual end customers out in the world. I'm going to give two examples of not thinking about the customer. Firstly, load testing a service which is barely ever used by customers in the real world, just because someone told you to do it. Now that's not a good use of time. I think the worst I ever saw was a business flow which was load tested on a regular basis and had a peak load of 3 transactions an hour. What a waste of time, right? The other example of not thinking about the customer is monitoring a bunch of technical metrics, often, screeds of data, but not being able to answer simple questions such as, what are the customers doing right now? And what was the impact of that change we made last night on the customers today? Is there an impact? Have we had any material impact on our business? Something else to watch out for is how much time you're spending load testing and monitoring in pre-production environments rather than actually spending time in production in the real world. Every test, everything we do in a pre-pod environment is an approximation of the real world. There's still risk out there, and there is no better place to actually understand performance than in production, if there is a production service to refer to, right? This is genuinely one of the things which interested me to SRE. I found myself doing all of this testing and activity in pre-prod, but not really knowing once that code or that change has gone live in production, what happened, what the customers were doing. Were all these tests which we were running actually reflective of what happened in the real world? Sometimes I couldn't answer that question, and I felt like there was so much more opportunity in production than there was spending all this time testing in pre-prods. Second piece of advice, and not enough people do this, look at raw data. So what do I mean by that? Real clear, let's say you run a load test. You make 100,000 requests during that test. By looking at the raw data, you would see a scatter plot, and there would be a point for every single one of those 100,000 transactions that you completed during your test. We don't generally see that in our load testing tools. There is some kind of aggregation. We'll see a line chart or a bar chart or a single number. That'll be an average or a percentile. Now, whenever we aggregate, we lose information, and it makes it harder to see and understand what the system behavior is and to identify and resolve patterns and issues. I cannot say it enough. Raw data is the key to great investigation and diagnosis of issues. The thing is, most load testing tools don't support it out of the box, so you probably need an additional tool to really get your data analysis lifted to the next level. I use Tableau. It's a BI analytics tool. It does cost money. RStudio is open source and free. You could use Power BI if you have it. There are other tools available as well. Whatever tool, I encourage you to investigate and start looking at raw data and see what you see and tell others about it, because not enough people are doing it. Tip number 3 came from my mentor, Neil Davies, who taught me about the divide and conquer approach to diagnose and investigate an issue. It's very simple. Let's say you have a solution and you have a transaction which flows through 10 different components. And let's say it's really slow. Let's say it takes 20 seconds and you want to know, where is the time being taken? Where is it slow? So the basic approach is pick a point in the middle. Maybe there's a web server somewhere in the middle of that flow. Go into that web server, whatever monitoring you have. Maybe you've got logs, maybe you've got traces, maybe you've got something else which gives you timestamps and timings. Go into that point and see how long it's taking. If it's slow at that point in the middle, then you know that the problem is either in that layer or somewhere downstream. However, if it is fine, it's fast at that point, then you know for a fact that the issue is somewhere upstream. Now, of course, there are all kinds of complexities around whether calls are being made in parallel and asynchronous activity and all those kinds of things. But the basic approach of divide and conquer has helped me infinitely in my ability to think about and diagnose and investigate issues over the years. So give it a go. Tip number 4, write your own tools and products if you need them. You will find yourself in situations where you won't have a tool that can do the job you need, or the tool that you do have is clumsy or not up to par. So write your own tool, make it available to others. It's part of being a performance engineer rather than someone who just does load testing. Now, here's some examples of things that I've written, some code that I've written over the years. Lots of utilities about transforming data, taking logs and converting it to a format I can analyze in Tableau or some other tool. A lot of that, or to access databases and retrieve information for test data and then putting it somewhere before a test. Automation type activity. A couple of sort of more producty type things I've developed. JMeter's out-of-the-box data pool handling. Doesn't provide the functionality that I was after. I wanted consumable data, random access of data, and so there is a plugin for JMeter called the Simple Table Server, STS. I developed something very similar, but as a standalone Node.js application, and it was set on a server, ran 24/7, and we used it for all our test data. Very handy, very fast, and that's an example of using code to create your own utility and tool to make your life easier. If you're uncomfortable writing code, get comfortable. It's not that hard. There are so many incredible languages out there where all you have to do is know the basics and then just call libraries, and they do most of the work for you. Tip number 6 goes back to a blog I wrote a bazillion years ago called The Myth of Continuous Performance Testing, where I criticized the idea that we could automate all of load testing and performance testing and analysis. And my point here is that get it right manually before you try and automate it. Don't try and run before you can walk. Now, there's been so much focus recently on automation and process automation and pipelines and CI/CD. If you just jump on the bandwagon, you're just going to create all this technical debt which doesn't solve any problems. Think about what you're doing first and simplify it and make it robust and make it so that it's actually effective in providing value. When you're at that point, then you can start thinking about automating and think about what you can automate and what's useful to automate and what's not. So we want to automate toil work, repetitive manual work, rather than creative work which requires a human being to really think about and analyze something from different angles. And that's not to say that, algorithms and machine learning and AI aren't coming along, but there's a long way to go, and it's important that you get things right manually before you try and get the robots to do the work for you. Tip number 7, I think I'm up to, is to record what you learn. Have a knowledge base for yourself, for your team, for your organization. It is incredibly powerful and important. Now, how often have you been in a situation where there's a performance engineer working on a platform or a project and they leave, and the next person who comes along is like, what am I supposed to be doing? It's just not good, is it? It's a difficult thing to hand over. at times. But putting down that knowledge and getting it out of your head and down somewhere is incredibly important, because it breaks that dependency on you and what's in your head. And you might think you want to hoard the information for yourself, but it just hurts you in the long run. And it doesn't do justice for performance engineering as an industry. At the very least, the one thing I would suggest doing is to create a test execution guide. So it is a step-by-step playbook on how to run a particular performance testing suite, if load testing is your focus. But it could apply to anything that you're doing. So the test execution guide. And write it in such a way that someone new to the team could come in, follow the instructions, and be able to do it. Even if you've automated it, still document it so that people can come back and understand what's happening so they can fix it later on if there's any issues. The other thing I would think about is how you store knowledge. Having documents in an organization spread everywhere that no one can find, or different teams use different documentation technologies, it can be really tricky. So a couple of things on that. Try and find some technology which lets you enter knowledge chaotically, but that knowledge is easily found. So simple example, Wikimedia, the platform which Wikipedia is built on. MediaWiki, that's the name of the technology. That's the technology that Wikipedia is built on, is a pretty good example of that. You can enter information on any page. You can write links to pages which don't exist yet, and when they do appear, they'll start linking together. It's very searchable. That's a good example. I know Nicole van der Hoeven, I hope I said it right, is big on this as well, and she uses, I forgot the name of the tool she uses now, but my colleague uses something called Joplin, which is a tool meant for helping you do better knowledge retention. And we use Confluence at work and as well, and that's okay. That's not perfect. You need to kind of structure what you do, but picking a tool that suits you and your team is very helpful. And there's an idea that some other people at my organization had recently, which is an internal question and answer site like Stack Overflow, where people can ask questions and people can respond with links to different documents or knowledge repositories to help them. So the Q&A site becomes an index to get information which may be spread all over the organization. I think that's awesome, and I'm really looking forward to implementing something like that at IAG. Tip number 8, use a risk-based approach. What does that mean? I see people use the word, we're going to use a risk-based approach all the time, and then just follow the same process they did last time and the time before that, based on some word template from 15 years ago. That's not risk-based. How can you come up with a strategy for performance testing or monitoring or anything in the performance engineering space if you don't understand where the business risk is? Because the whole idea is that your performance engineering work is trying to stop bad things happening. So if you don't know what the bad things are that might happen, how can you stop them? Yeah. My advice is to do a risk-based approach and actually assess the risk. Think about the customers and the different kinds of customers that are going to be using this. Think about the workload that those customers are going to put on your services. Think about the business criticality of each of those services. Think about the technical complexity of those services and how much work they're going to be doing. Think about how hard it's going to be to test each of those services. If you don't think about these things, then you're going to make bad decisions and you're going to do suboptimal performance engineering work. Tip 9, think beyond load testing. Load testing has been the bread and butter of performance testing and performance engineering for decades, but it is a decreasingly important part of the work that we do because systems are becoming so complex and we are delivering so quickly that building a complicated, costly load testing suite, it's going to provide value with too much cost, too late, and we need to adapt. So think about other things that you can do. It could be leveraging test automation to get single user timings. It could be doing web analysis using a tool like Fiddler or Chrome developer tools. It could be using APM tools, tracing tools, and logging tools in either production or non-production environments. It Could be thinking about how we deploy code to reduce risk. So canarying, red, blue, green releases, anything like that. Think outside the box and get involved in all these other aspects that can help stop performance disasters happening and can help make our systems more reliable and the customers have a better experience. Because if you just keep focusing on load testing, I suspect that you will fall behind in the industry and there will be less opportunities for you in the future. And you'll probably be less satisfied because you'll be providing less and less value in what you do. For those of you just starting out in the performance engineering world, it can be really difficult. I get people reaching out pretty frequently on LinkedIn asking for help and advice. It is difficult across different parts of the world to help people, but if you can find a mentor who is somewhat local to you in terms of time zones, ideally someone in the same city that you can meet, even better if they work in the same organization. Having a mentor who really knows what they're doing and to be able to work with them is the key, I think, to my career and the confidence that I have now. My mentors taught me so much about not just what I learned, but they taught me how to think about performance as a field and how to teach myself. I'm fairly independent now, but it took a long time to get to that point. So if you can, find a mentor. If you are an experienced performance engineer, then I say to you that you need to be an advocate for performance. So what does that mean to be an advocate? Well, one thing on the previous point, take the time to teach others about performance engineering. If there are juniors who are interested and want to become performance engineers, help them. It's in your best interest, it's in everyone's best interest to raise the profile of performance and get better quality work happening all over the world. But you also need to be an advocate within your organizations to speak to stakeholders, other engineering groups, leadership, business representatives, to help them understand why this stuff is important and to cut through all that complexity so that people understand and can relate to what you're doing. And it makes such a difference. And I know that it's challenging to do presentations and to understand how to speak to different stakeholder groups. That's not what a lot of technically minded engineering people like to do, but it's important, and ultimately you will achieve so much more if you get involved in advocacy than you will if you just sit at a computer and do hands-on engineering work. You're going to have to trust me on that one. Last tip, and it turns out I actually pretty much went through every single thing in the blog, it's kind of personal to me, is to care about the work you do, but not too much. Don't let it get to the point where it's impacting your personal life because you're stressing out about not delivering something or something's not working right. There are so many things outside your control as a performance engineer. All you can do is show up each day and do your best and try and do what's right for good performance and for the customer and business outcomes. Don't get caught up in politics if you can avoid it. And if you're in a situation where you're on a death march, just being told to deliver without any thought about whether it's valuable or not, then my advice would be try and get out of that situation. That's not good for your health or for anyone if you can avoid it. So yeah, just look after yourself. You don't want to end up like I was, unable to sleep, on medication, and just wanting to escape from work because I took it too personally. I took too much of it in. Don't be me. To close, I'd like to make a few acknowledgements, as I did in the blog, to people who've made a massive difference to me in my career and actually my life as well. So the first person is Stan Scappers, who hired me for my first job as a performance engineer in Wellington in New Zealand. You got me started in this amazing field. We've become great friends. Flying to Europe and seeing you at the Neartus PAC conference has been amazing, and it's great to stay in contact with you. Neil Davies, you were my primary mentor through most of that early stage of my career. You taught me so much about how to think about performance, how to investigate issues, you gave me a love for data and analysis and writing tools to solve problems. And speaking of data analysis and visualization, the Zen master himself, Richard Leake, thank you so much for building such an incredible performance engineering community in New Zealand, and for the times that you helped me work through situations and issues around performance. Your knowledge is immense, and you are such a humble person and so easy to talk to. Ben Rowan and Shirali Apana have been peers of mine in the performance engineering field for many years, and I've enjoyed working with you both and being able to call up and bounce ideas off you when I was in situations where I didn't know what to do has been a lifesaver. And you are such a benefit to the industry, and I look forward to seeing what you guys do in the future. To all of the people who create content and speak at conferences and write blogs and engage the community around performance engineering, you guys are doing such an amazing job at increasing the profile and interest in the field. There's too many people to name, so I only mentioned a few, but there's Andy Grabner, James Pulley, Alexander Padelko, Mark Tomlinson, Leandro Melendez, Henrik Rexed, Scott Moore, and Nicole van der Hoeven, among many others. You give guidance and context, and you help people, and keep doing what you're doing, and hopefully more people will join in and help be advocates for this fantastic field of work. Special call out to all the people involved in creating the Neotis PAC conferences in the past. Flying from New Zealand to Europe is a huge journey, but also some of the biggest adventures I've had in recent years. So Henrik Rexeds, Stefan Burnett, Laurent, thank you so much for all the effort you put into creating those really special conferences. And lastly, a thank you to the grads, or the people that I guess I've mentored over the years. So that would be Paul Zhang, Cynthia Tan, Owen Hugh, Raina Chand, and Gwen de Leon. Teaching you has been a true joy, and it helps me learn along the way, and your fresh perspectives and energy have kept me young on the inside, but not so much on the outside. So, I'm not closing the door on performance engineering. I am exploring another area at the moment, which I am really enjoying, and I'm looking forward to seeing where it goes. But performance engineering is such an interesting field of work with infinite possibility, infinite depth of complexity, and breadth of scope as well. So watch this space, and I hope you continue to stay listening in to my content, which will from now on be SRE focused in my new series, Slight Reliability. For the final time, for now, logging off for performance time. My name is Stephen Townsend.